In this example, we take you through the steps of drawing the free body diagram for the subsystem consisting of the plates A and B and the springs between them. The first step is to define the subsystem, which can consist of one or more bodies. In this example, the subsystem is predefined as plates A and B and springs C and D. In the future, this step will require a decision as to which subsystem needs to be analyzed. The second step is to draw the bodies of the subsystem together as they appear in the original system. This step is usually straightforward, drawing the outline shape of the subsystem. The third step is to identify places where the subsystem interacts with bodies outside the subsystem and the centers of gravity for all the bodies in the subsystem. This step requires you to carefully consider which bodies interact with the subsystem. Stop for a moment and think about how to do this. When you're ready to continue, click the play button. The subsystem is contacting springs A and B, as well as the cables holding the masses. The contact points are identified with green points. The weights of the parts of the subsystem are neglected, so no gravitational forces act on these members. That is, the interaction between the members and the Earth is neglected. The fourth step is to draw all the force vectors exerted on the subsystem by the Earth and the bodies interacting with it. This step requires you to carefully consider the various attributes of each of the forces. Pay close attention to their direction, sense, and point of application, and label each force with a known or unknown magnitude. Stop again and think about how to do this. When you're ready to continue, click the play button. Here are the relevant forces. The force of spring A acts away from the subsystem since the spring is stretched. The unknown magnitude is labeled S sub A. The force of spring B acts away from the subsystem since the spring is stretched. The unknown magnitude is labeled S sub B. The force exerted by the cable with the 50-pound weight acts away from the subsystem. Its magnitude is known and labeled as 50 pounds. The force exerted by the cable with the 100-pound weight acts away from the subsystem. The magnitude is known and is labeled 100 pounds.